Firefly sunsets Blue Ghost's first lunar mission, China proposes to build a large modular space telescope with some familiar attributes, Starliner make it a third try at an uncrewed mission, and finally, Suni and Butch are back on dry land. As always, we have all that and more coming up this week in Spaceflight. Firefly's Blue Ghost lander ended its mission this week, closing out an all-around successful first flight for the spacecraft and gathering some unique lunar science. Blue Ghost's journey began on January 15th, launching on board a Falcon 9 rocket that sent it into a highly elliptical orbit around Earth. The spacecraft then spent 45 days orbiting Earth before departing for lunar orbit, where it waited for the right illumination at the landing site to land. The lander successfully touched down on Mare Crisium on March 2nd, kickstarting a 2-week period of surface operations. During those 2 weeks, Firefly was able to command all payloads on board Blue Ghost, receiving dozens of gigabytes of science data in return. One of those payloads was Luinstra, a pneumatic gas-powered drill that measures the temperature and flow of heat from the moon's interior. Another was NASA's SCALPS payload, which stands for Stereo Cameras for Lunar Plume Surface Studies and consists of a series of cameras pointed at the ground to observe the interaction between the lander's thrusters and the lunar dust as it landed. The payloads provided a wealth of knowledge, but perhaps one of the most exciting events during the mission was the lunar eclipse that Blue Ghost observed last week, showing an amazing diamond ring around the Earth as our own planet occulted the sun from the moon's perspective. Blue Ghost not only gathered observations from that, but also was able to record the data from its payloads while the eclipse was happening, including that drill that we mentioned before. Blue Ghost's landing took place just a few hours after sunrise over the landing site, so after 2 weeks, it was time for sunset on the moon. The lander was programmed to operate during and after sunset for at least 5 hours, capturing the setting sun behind the lunar horizon. The images gathered by Blue Ghost confirm observations made by the Apollo astronauts that, as the sun sets, its color turns greenish. The lower exposure shots also show the planet Venus, as well as Earth as the sun disappears. With this last major event, Blue Ghost's mission is now complete. But is it the end? The lander was never built to survive the harsh conditions of the lunar night, but as we've seen in the past, you really never know what could happen. For that reason, Firefly will try to contact Blue Ghost at the beginning of April and see if it's still alive.
I'd say the probability is very, very low that we do power back on. Maybe we will get a signal, in early April, and we'll certainly let y'all know if we do.
We'll check in and let you know what happens in a future episode. And if you don't want to miss it and want to stay up to date with everything spaceflight, be sure to like and subscribe and tune in whenever we go live. We got a lot of news about space telescopes and astronomy this week, so much so we're going to make a whole segment about it. Let's start off with the James Webb Space Telescope, which has been the workhorse of infrared astronomy since it came online a few years ago. This week, astronomers published Webb's images of 4 planets that orbit a star called HR 8799. It's located 130 light years away, which is actually just around the corner in astronomical terms. At only 30 million years old, this planetary system is very young. Our own solar system is 4.6 billion years old. So yeah, this one is really just a baby. And because of that, astronomers are very keen on studying the system to learn more about how planets form. Now, what's special about Webb's observations is that the telescope imaged the exoplanets directly. Most exoplanets are discovered through indirect methods, in which astronomers study the light spectrum of a star over a period of time. This allows them to observe how the spectrum changes ever so slightly as the planet orbits the star. Now, that might sound difficult, but observing planets directly is even harder. The biggest challenge is the star itself, which outshines any planet around it. But Webb has a way to deal with that. It can block the light of the star, allowing the telescope to focus on just the planets instead. That's why the star itself doesn't show up in the image, but the astronomers did add a little star symbol to show its position. If Webb didn't block the starlight, the image would be completely washed out and we'd have no chance of seeing those faint planets. Of the nearly 6,000 exoplanets known today, only a few dozen have been imaged directly this way. However, the planets in the HR 8799 system are very well studied, and they were first observed directly in 2008. Astronomers have so many images of these planets that they were even able to make a time-lapse video of them orbiting their star. So what makes these fuzzy blobs in Webb's image so special? Well, it's the best image that we've gotten of the planet so far. Webb was able to block the starlight and observe the system's planets in a way that we've never seen them before. What's more, Webb observed the planets in different colors of infrared light, allowing the astronomers to study the planets' compositions. It turns out that these planets are rich in carbon dioxide and contain more metals than expected, indicating that the planets may have formed in a similar way to the gas giants in our solar system. Crucially, these images also confirm that Webb has what it takes to do this type of science, and it's only a glimpse of what's to come when Webb sets its eyes on some less familiar planets. And now on to China's proposal for a new space telescope. Images of the proposed observatory surfaced this week, and let's just say they look pretty familiar. Yep, it looks a lot like Webb. The proposed telescope has a large segmented primary mirror and also a very similar looking sunshield. But looks can be deceiving, and that seems to be the case with this one. It's going to be very different in some ways. Let's start with the shape of the telescope. Its primary mirror will have a diameter spanning 10 meters, much bigger than Webb's 6.5 meter mirror. This telescope is expected to weigh 17.9 tons, whereas Webb came in at a meager 6.5 tons at launch. So how is China planning to get this behemoth into space? Well, the plans call for multiple launches, likely using the country's Changzheng 5 heavy lift rocket to bring up the telescope in parts. These parts will then need to be assembled in orbit, and they've got two plans. One seeks the help of the Tiangong space station and its robotic arm, while the other adds a robotic arm to the telescope so it can assemble itself. Because of this, the telescope is also known as the On-Orbit Assembling Space Telescope. Now, this isn't the first time we've heard of this concept, as it's been making the rounds for a few years as a collaboration between China and Russia. According to these plans, the telescope will be able to observe in both ultraviolet and infrared, while Webb is limited to only infrared. But the telescope looked very different in those early plans, so it's not clear how much of that concept remains. We don't even know if Russia is still involved. But what we do know is that these plans sound like a complicated but very cool way to build a space telescope. Continuing our space telescope news, this week the European Space Agency released the first batch of data to the public from its Euclid mission. Euclid was launched in 2023 on a 6-year mission to survey nearly a third of the sky, seeking the nature of dark matter and dark energy. Since then, we've gotten a few spectacular glimpses of what this telescope is capable of, but they pale in comparison to this latest release. This week's 3 images are a preview of Euclid's deep field images. These are all areas of the sky that Euclid will explore many times throughout its mission, between 30 and 52 times, in fact. Each time Euclid trains its instruments on these patches of sky, the resolution improves, and Euclid is able to see even more distant objects. That's why these images are called deep fields. In total, they cover an area over 300 times the size of the full moon, so there's a lot to see in them. One particularly beautiful sight is the Cat's Eye Nebula, which is 3,000 light-years away and is made of the leftovers of a dying star shedding its outer layers. The result is really stunning, but Euclid scientists are much more interested in the galaxies in the background. There are 26 million of them, some as far as 10.5 billion light-years away. But there are way too many out there for any given astronomer to look at, so how do scientists study all of these galaxies? Well, Euclid's team got some help from nearly 10,000 citizen scientists from the Galaxy Zoo project, who all collaborated to teach AI to recognize different shapes of galaxies in the images. But they didn't just find different shapes, but also galaxies that distort the light from galaxies even farther away through a process called gravitational lensing. Euclid found 500 strong lens candidates, and almost all of them were previously unknown. These distortions, as well as the much subtler weak variant of gravitational lensing, will help Euclid to unravel the mysteries of dark matter and dark energy. These images might just be a preview, but Euclid scientists have already written 27 scientific papers using them. This wealth of data is now available to everyone around the world, scientist or not. If you want to have a look at these galaxies yourself, the images are now available in the STScI tool. Now we'll take a look at some other stories across space, starting with a story from under the sea? Yep, don't worry, it makes sense because there's also a satellite involved. The Surface, Water, and Ocean Topography, or SWOT mission, which NASA collaborated on with the French space agency CNES. The satellite launched on a Falcon 9 in December of 2022 and is outfitted with a radar instrument that's able to precisely measure all of the bodies of water on Earth's surface. While it only looks at the surface of all of this water, it turns out that it could also reveal what's going on at the very bottom. The ocean floor is covered in hills and mountains, and all of these ever so slightly add to the gravity pulling on the water above. So the ocean surface is slightly bumpy as a result. We don't really notice this, but SWOT's instruments are so precise that they can measure these small bumps and detect undersea hills lower than half a kilometer. SWOT's mission was never to map the sea floor, but it did it anyway. These accurate maps can now be used for a whole range of undersea activities, from navigation and laying communications cables to studying the geologic processes that happen down below. This week, Roscosmos rolled out the first test article for its latest rocket, the Soyuz 5. The vehicle is also known as Irtish, and it's been in development for almost 10 years. It's planned to replace the lost capabilities of the Ukrainian-built Zenit and the Proton medium lift carrier. Its design keeps it compatible with the Zenit pad's infrastructure, and it can take advantage of existing tooling for the Proton rocket. The vehicle will initially have 2 stages, and for geostationary missions, a third Block DM-03 upper stage can be added, which has already flown on 8 missions to date on other rockets. The second stage will actually be more efficient than the Zenit one thanks to a wider 4.1 meter diameter and a new variation of the RD-0124 engines that currently power the Soyuz 2.1 and Angara rockets. The first stage could also be clustered to power yet another new rocket in the future, a planned super heavy launch vehicle dubbed Yenisei. After several years of development, the fully integrated first stage rolled out of the Samara manufacturing site in southern Russia this week and will now conduct engine firing tests. The Soyuz 5 is expected to take its maiden test flight by December of this year from the Baikonur Cosmodrome in Kazakhstan. The French rocket company Space announced its first commercial customer this week. The company signed a contract with another French company called ExoTrail to launch multiple missions starting in 2027. ExoTrail offers space logistics with its Spacevan spacecraft, which is designed for multiple purposes such as hosting payloads or delivering satellites into their final orbits. The spacecraft already has some flight experience, as ExoTrail's first Spacevan flew on SpaceX's Transporter 9 mission in 2023. Now the company is collaborating much closer to home. Space is working on a small methane-powered reusable rocket, and some of its first commercial payloads will be provided by ExoTrail. Now, if you want to learn more about Space's rocket and how it's progressing towards its first launch in 2026, we've got just the show for you. Earlier this week, we interviewed Space CEO Yoann Leroy for our NSF Live series on YouTube about Europe's future in space. Following Crew 9's successful splashdown on Tuesday, which we'll cover later in the show, NASA's Steve Stitch confirmed that NASA is working with Boeing to go through Starliner certification to get it back to flight. What has not yet been finalized, though, is whether Starliner's next flight will be carrying people or not. The agency is still working with Boeing on understanding and fixing the helium seals and thruster issues that led to NASA astronauts Butch Wilmore and Suni Williams' prolonged stay on the International Space Station. Stitch stated that teams will begin testing a new fix for the thrusters this summer. He also said that it would depend on the outcome of that testing and the other work required to get Starliner through certification as to that final decision on whether or not to fly with a crew. If Starliner needs to fly again uncrewed, that really wouldn't be a great sign. After all of the troubles that the Starliner program has already gone through, that mission, or any Starliner flight for that matter, would definitely be under a lot of scrutiny the second time around. So here's hoping that things move much more smoothly in the future. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This week was another very busy one. Let's begin in New Zealand with the first of 2 Electron launches this week. The first mission, called the Lightning God Reigns, began on March 15th at midnight UTC from Launch Complex 1B at Rocket Lab's own launch site in New Zealand. The mission was carrying the 9th QPS SAR satellite for IQPS into low Earth orbit. The satellite, fitted with a large but lightweight deployable antenna, can perform high-resolution synthetic aperture radar observations of the Earth. From New Zealand, we'll go next to China with a Changzheng 2D rocket. Liftoff took place on March 15th at 4:11 UTC from the South Launch Site 2 at the Zhoushuan Satellite Launch Center. The mission was carrying the second SuperView Neo-3 satellite into sun-synchronous orbit. SuperView Neo-3 satellites are Chinese commercial Earth observation satellites observing in the optical side of the spectrum. Along for the ride was also the Tianyang-23 satellite, another small Earth observation satellite in the optical range. A few hours later, we had a Falcon 9 launch from Vandenberg with SpaceX's Transporter 13 mission. Liftoff took place on March 15th at 6:43 UTC from Space Launch Complex 4 East. Falcon 9 was carrying 74 different payloads into sun-synchronous orbit. Transporter 13 is SpaceX's latest launch as part of its small sat rideshare program, the 15th overall and the 13th of the Transporter-type missions. Some of the notable payloads include Varda's third Winnebago spacecraft built by Rocket Lab, which launched just a few weeks after the return of the previous Winnebago 2 spacecraft that launched on the last Transporter mission. There are also multiple Earth observation satellites, including Albedo Space's Clarity 1, a small satellite built to orbit the Earth at very low altitudes to capture images of the ground in high detail. On this mission, there was also an orbital tug from D-Orbit called Ion SCV-017 Marvelous Matthias, which carried several of the payloads flying on this mission that were either hosted on the spacecraft or that will be deployed at a later time. For a full rundown on all payloads on board Transporter 13, NSF's Danny Lentz wrote an in-depth article for our website with an overview. For this mission, SpaceX used booster B1081, which flew for a 13th time. After stage separation, the booster returned back to the launch site at Landing Zone 4 to be reused on a later flight. Just a few hours later, we had another Falcon 9 launch, this time from Florida. Liftoff happened on March 15th at 11:35 UTC, carrying a batch of Starlink V2 Mini and direct-to-cell satellites into low Earth orbit. This launch broke the record for shortest pad turnaround time by SpaceX, going from 2 days, 15 hours, and 53 minutes, down to 2 days, 8 hours, 59 minutes, and 30 seconds, so essentially 30 seconds short of 57 hours. This also marked the third launch by SpaceX in 12.5 hours, a record for the company, having launched the Crew 10 mission, which we covered in last week's Space Traffic, this Starlink launch, and the Transporter 13 mission. For this mission, Falcon 9 carried booster B1078 on its 18th flight, and it successfully landed on SpaceX's drone ship. Just read the instructions. This week, we also had an Angara 1.2 rocket from Russia. The mission took off on March 16th at 10:50 UTC from Site 35-1 at the Plisets Cosmodrome in Russia. The rocket was carrying 3 classified payloads for the Russian Ministry of Defense into low Earth orbit. It's believed, however, that these may be Rodnik military communications satellites based on the orbits in which the spacecraft were dropped off. Heading back over to China, we had a Series 1 rocket taking off on March 17th at 8:07 from Site 95A at the Zhochuan Satellite Launch Center. The mission, called Auld Lang Syne, carried 8 satellites into sun-synchronous orbit. All 8 payloads on board were Earth observation satellites. 6 of them were Yunya-1 satellites, and the other 2 were the AirSat 6 and 7 spacecraft. And as mentioned before, this was a rare week as we had 2 Electron launches back-to-back from New Zealand. The second of these missions, called High 5, soared high on March 18th at 1:31 UTC from Launch Complex 1A at Rocket Lab's own spaceport. The mission carried the final batch of 5 Kinéis Internet of Things satellites into a sun-synchronous orbit. This launch marked the shortest time between 2 orbital launches of the Electron rocket, thanks in part to the existence of 2 separate launch pads at the same spaceport. Stick around though, because there's another one coming up next week. You'll see later. This week, we also had a return from space with the Crew 9 mission coming to an end. As is traditional, in order for the crew to return from the International Space Station, the next one has to already be up there. Now, in case you don't remember, last week, SpaceX launched the Crew 10 mission on March 14th at 23:03 UTC. Crew Dragon Endurance, which flew on that mission, docked to the front docking port of the ISS Harmony module on March 16th at 4:04 UTC. On board were NASA astronauts Anne McClain and Nicole Ayers, JAXA astronaut Takuya Onishi, and Roscosmos cosmonaut Kirill Peskov. The 4 crew members will now join the crews of Expedition 72. With Crew 10 at the ISS, NASA and SpaceX prepared for an expedited return of Crew 9, taking advantage of favorable splashdown weather in the days after Crew 10's launch. Crew Dragon Freedom, which flew on the Crew 9 mission, undocked from the Zenith port of the Harmony module on March 18th at 5:05 UTC. Following a series of separation burns, Freedom and the crew of Crew 9 orbited the Earth for 15 more hours, waiting for the right alignment of their orbit with the splashdown site. Dragon jettisoned its trunk and started its deorbit burn at around 21:11 UTC, pulsing its forward Draco thrusters for about 7.5 minutes. The capsule successfully returned back to Earth, splashing down at 21:57 UTC in calm blue waters off the coast of Tallahassee, Florida. The 4 crew members, NASA astronauts Nick Hague, Suni Williams, and Butch Wilmore, as well as Roscosmos cosmonaut Alexander Gorbanov, exited the spacecraft and departed for Houston, where they were greeted by friends and coworkers. With this mission, Hague adds about 171 days to his total time spent in space, for a total of nearly 374 days of accumulated time. Gorbanov, who was flying for the first time, now gets to log those 171 days as part of his own space career. For Suni and Butch, their time is even longer, as they went up to the station as part of the crew of Boeing Starliner's crew flight test mission. Both astronauts now add about 286 days to their careers, coming in 6th place in the list of astronauts with the longest single mission stays in space. In total, Suni and Butch have accumulated a total of 608 days and 464 days in space, respectively. With this return, their mission comes to an end. A mission that, albeit had a wrench thrown at it early on, resulting in the crew being incorporated into the next crew rotation mission. Events that we've been covering at NSF for quite a long time. Now that the crew of Crew 10 is on the station, we can look forward to some major upcoming events, including the departure of the NG-21 Cygnus spacecraft next Friday, March 28th. In April, we also have the next Soyuz crew rotation mission, with the Soyuz MS-27 scheduled to launch no earlier than April 8th, followed by the Soyuz MS-26 spacecraft departing no earlier than April 20th. SpaceX is also planning a Dragon cargo resupply mission in April, followed by a private Axiom crew flying to the orbital outpost in late spring. The crew of Crew 10 should remain on station until mid-July, when the Crew 11 mission will launch to the ISS to repeat the cycle on the next crew rotation mission. Believe it or not, there were even more launches. Next, we had another Falcon 9 launch from Florida. Liftoff took place on March 18th at 1957 UTC from Space Launch Complex 40. The mission was carrying a batch of Starlink V2 Mini and direct-to-cell satellites into low Earth orbit. The first stage for this mission, B-1077, was flying for a 19th time, and it successfully landed on SpaceX's drone ship, a shortfall of Gravitas. With the 2 Starlink launches this week, SpaceX has now launched a total of 8,131 Starlink satellites into orbit. 1,003 of them have now re-entered, and 6,470 are in their operational orbit. We had another Falcon 9 near the end of the week from Vandenberg. The rocket was carrying out the NROL-57 mission for the National Reconnaissance Office. The mission was the 8th in support of the NRO's proliferated space architecture constellation, which makes use of SpaceX's Starshield satellites. The number of satellites on this mission is unknown, but it couldn't have been too high, as the Falcon 9 booster had enough performance to attempt a return to launch site. Another interesting fact about this booster, B-1088, is that it flew last week in support of the launch for NASA's Sphere-X and Punch missions. This breaks the record for shortest turnaround time of a Falcon booster, at just over 9 days between the 2 missions. And to round out the week, we had another Series 1 launching again. The mission, called Vernal Ascent, lifted off on March 21st at 11:07 UTC from the Zhochuan Satellite Launch Center in China. On this mission, Series 1 was carrying 6 Yunyao-1 meteorological satellites into a sun-synchronous orbit. Going into next week, NASA's Parker Solar Probe is set to again come close to the Sun, making its 23rd perihelion. This close approach will also be the second since the probe flew by Venus in November, which changed its orbit and brought it the closest ever to our own star. This means that the Parker Solar Probe will once again encounter extremely high temperatures like the ones from the closest approach back on December 24th, so NASA expects to get a lot of data out of this. Starting off next week, we'll have the launch of ESAR Aerospace's Spectrum rocket from Andøya in Norway. Launch is targeted for no earlier than March 24th, within a 3-hour launch window that opens at 11:30 UTC. ESAR has multiple daily opportunities through March 30th. Good luck on what could become the first orbital launch from mainland Europe. Next week, we'll also have more Falcon 9 launches, including the launch of the NROL-69 mission for the National Reconnaissance Office from Florida. The 42-minute launch window for this mission is set to open on March 24th at 1742 UTC. The first stage is expected to make a return to launch site landing, so expect sonic booms if you're in the area. After having to stand down from an earlier launch attempt due to range conflicts, Firefly will again be trying to launch its 6th Alpha flight next week. The mission, called Message in a Booster, is currently planned to take place during a 69-minute launch window that opens on March 26th at 13:37 UTC. As mentioned earlier, Rocket Lab has yet another Electron launch coming up next week. The mission, called Finding Hot Wildfires Near near you is set to take place within a 30-minute launch window that opens on March 26th at 15:30 UTC. Next week, we'll also have a Starlink launch from Vandenberg, carrying more internet satellites into orbit. The 4-hour launch window for that mission is set to open on March 26th at 2200 UTC. And that's your weekly update of spaceflight news. I'm Elysia Segal for NSF, and we'll see you all again next week to recap this week in spaceflight.